So this video is for a micro mouse which is made using image processing. We've used OpenCV, which are a set of libraries used in C. So the entire code is made in Visual Studio and written the code in C++. So as you can see, this is showing the actual image of the track which is obtained from this particular camera which is mounted in the overhead ceiling. So it is giving me the entire view of this track. This track, the blue part is the wall, and that green and the pink part you can see is the board. So the main aim is to perfectly detect the board and the wall. So the final code will be running the board in a way so that it enters from the opening on the bottom and exits from the opening on the top and follows the path which is shown by the hand. So this is the first step of the entire process in which we are just doing the color detection. We are not processing it right now. So we've precisely got the color of the board and the walls distinctively, as you can see in the binary image on the right hand side. And the speed is pretty good as we are using OpenCV. It's all real-time processing. So we are streaming the video and showing the binary image at the same time. Now that we are done with the first stage of the bot, which was color detection, we move on to the second stage where we now have the precise coordinates of where the wall is and where the coordinate of the bot is. So now comes the main part where we decide the path which the bot has to travel. Now for that we've divided this track into a number of grids where each grid represents a node. This grid is made by cropping the image of the map into n number of grids. Now we call each grid as a node, and it is either connected to the next node if there is no wall between the two nodes, or it is not connected to the two nodes if there is a wall between the two nodes. So now we've segregated each grid into parts by saying whether it's connected to the next node or not. And then using this concept, we've created an entire tree of the map on which we are applying the Dijkstra's algorithm and finding the shortest path for this map. Now, in this case, we used a very simple map where we have only two rows. The concept was if it works on this, it has to work in an entire arena for a micro mouse. So this one's the demo of the final bot. We've combined the color detection and the Dijkstra's algorithm, and we made the micro mouse. This is the demo of the image processing micro mouse where it's entering from the top opening and it is expected to successfully leave from the bottom opening. Since this was the first testing for the board, we've kept it on minimum speed. We can optimize it for higher speeds also on the same algorithm, and this is how the bot works.